So in this video, we are going to be reviewing the paper 2 from the 2018 iGCSE physics from CIE. Okay, so we're using a ruler to measure between 2 points. What we've done is we've got a cotton wrapped 6 times around a pen, and we're measuring the length of that cotton. So what is the distance once around the pen? Well, from the ruler we can get what the length is, and we've been told it's wrapped 6 times, so we can divide that number by 6 to get our value for one circumference. So when does an object falling vertically through the air reach terminal velocity? So terminal velocity means velocity is constant, which would mean acceleration is 0. So we can rule out the first two because they both suggest acceleration is not 0. And terminal velocity, the reason acceleration is 0 is the weight force equals air resistance. Okay, so our car is moving along a straight, level road with constant acceleration. Which graph shows the motion of the car? So the information I'm going to use is speed is the gradient of a distance versus time graph, and acceleration is the gradient of a speed versus time graph. So A indicates a car or that is not even moving because its distance is staying the same, not that one. Graph B shows constant speed because it's a constant gradient. C shows constant speed, and then D shows constant acceleration. We've got a straight line, which means constant gradient. So it's going to be option D. Okay, so diagram 1 shows a beam balance. A beaker with a wire loop balances the standard masses. The beaker is then removed and hung from a spring. The spring extends by 5 centimeters as shown. The experiment is repeated with the same apparatus on the moon, where the acceleration of freefall is less than that on the Earth. Which statement describes what happens on the moon? So before we even look at the answers on this one, the moments system is not going to be affected at all because both the left and the right rely on the weight force, and although the acceleration due to gravity is smaller, that's going to affect both sides. So diagram 1 we should see no change, but if there's a smaller weight force, there's going to be a smaller extension of the spring. So diagram 2 I expect to be shorter. So let's see which one of those. So we want one of the first two because the beam is still balanced, but the extension is less because the weight force is smaller. Okay, so an object always has mass but does not always have weight. What must be present and acting on the mass for it to have weight? We need a gravitational field to have a weight force. A force acting on a moving ball causes motion to change. This force stays constant. What makes the force produce a greater change in the motion of the ball? So essentially we're using F equals ma here. So if we have a smaller mass, that's going to give us a bigger acceleration for the same force there. And all the other ones actually would have no effect at all overall. So a balloon and a mass are attached to a rod that is pivoted at P. The balloon is filled with helium, a gas less dense than air, and that means there's going to be an upthrust force on the balloon, which in turn is going to apply an upwards force to the ruler, or the rod as it's called. So the rod is horizontal and stationary, so it's in equilibrium. So what action causes the rod to rotate clockwise? Okay, so we've got 4 different options. So to start with, what I've done is looked at the condition we've got. So with the balloon a distance of 30 from the pivot and the mass a distance of 20 from the pivot. And that gives us an expression for the force required from the balloon. Then what I'm going to do is talk about the moment. So it's going to rotate clockwise if the clockwise moment of the force is greater than the anti-clockwise moment of the force about P. So here is my table in each scenario of the clockwise and the anti-clockwise moments of the forces. And what we're looking for is one where the clockwise is bigger than the anti-clockwise, which we can see is option B. So what I've done in both columns is I've put them over the same denominator to make them easy to compare, but B is the only one where the clockwise is bigger than the anti-clockwise. The car is moving in a straight line on a level road. Its engine produces a forward force on the car. A second force of equal size acts on the car due to resistive forces, which describes what would happen. Well, it's going to go at constant speed. If the forces are balanced, acceleration is 0, so speed is constant. Which expression gives the momentum of an object? Momentum is mass times velocity. That's something you just have to know. So as energy is transferred into different forms, it eventually becomes dissipated. What does that mean? So dissipated essentially is the idea of energy spreading out among objects and the surroundings. So if we have a hot object in the middle of the room, eventually the room and that object become a uniform temperature. So we say that hot object has dissipated its energy. So a ball of mass 1.2 kilograms is dropped from a height of 30 meters. As it falls, 25% of its gravitational potential energy is transferred to thermal energy. What is the kinetic energy just before it hits the ground? So, first thing you can work out is how much GPE it loses by falling 30 meters, 360 joules. So we're told 25% is transferred to thermal energy, which means 75% will be turned into kinetic energy. So which is why it's 0.75 times 360 gives us 270 joules of energy. A girl hangs by her hands from the bar in a gymnasium. She pulls herself up until her chin is level with the bar. The mass of the girl is 48 kilograms. She pulls herself up through a distance of 0.25 meters, and she does it in 2 seconds. What is the useful power she uses to pull herself up? So first of all, I'm going to think, how do we calculate power? Well, it's going to be the amount of work she has to do divided by the time. Work is force times distance parallel to the force, and the force in this case, she is going to have to counteract her weight force, so that's why mg has been put in place of the force. So then once we've got to this point, we can plug the numbers in and we can see the power would be 60 watts. Okay, so we've got 4 identical beakers filled with equal volumes of liquids, and the liquids are either P or they're Q. Liquid P is more dense than liquid Q. At which point is the pressure the least? Well, it's not going to be in anything with P in it, because if it's more dense, that means there's a bigger weight force acting down, so that's going to give a greater pressure. So it's not going to be A or B. And then D is going to be lower pressure than C, because there's a smaller weight of liquid above D than there is at C. So that's going to allow us to select option D as the lowest pressure. Okay, so an oil tank has a base area of 2.5 meters squared, and it has oil to a depth of 1.2 meters. The density is 800 kilograms per meter cubed. What is the force exerted on the base of the tank due to the oil? So we're going to use this equation here would allow us to calculate what the pressure is, 9,600 pascals. And then what we want to do is turn that into a force by multiplying it by the area, and that gives us the answer option D. Okay, so when the molecules of a gas rebound from a wall of a container, the wall experiences a pressure. What is the cause of this pressure? So, pressure comes about due to a force acting over an area, and a force is created by a change in momentum. That's what Newton's second law tells us. So a student wishes to calibrate a mercury in glass thermometer with a degrees Celsius scale. Which values should she use for the lower fixed point and for the upper fixed point? So typically we use the 2 fixed points of water at normal atmospheric pressure to do this. So that's the melting point and the boiling point of water. Which statements about boiling and evaporation are both correct? So before we even look at them, boiling is when you get a change from liquid to gas at a constant temperature. Evaporation happens at below the boiling point, but evaporation only happens at the surface. So that's what we're looking for. So boiling can happen anywhere, so we can eliminate A and B straight away. But evaporation only happens at the surface, so that's option C. So on a cold day, a metal front doorknob X and a plastic doorknob Y are at the same temperature. Why does X feel cooler than Y? Well, this is all about thermal conductivity, and if you are a better conductor, you're going to remove thermal energy faster, which is why it feels cold. Our bodies measure temperature by the rate at which we exchange energy. So light travels at a speed of 2 times 10 to the 8 in a glass block. In the glass, the wavelength is 4 times 10 to the minus 7. What is the frequency? Okay, so we're going to use the wave equation. We rearrange it to make frequency the subject, plug the numbers in, and that gives us what the frequency is. Which arrow on the graph shows the amplitude? That is B, the distance from the center line to the maximum displacement. Scout P signals to Scout Q on the other side of the valley by using a mirror to reflect the sun's light. Which mirror position would allow this? It's going to be option A, because we need the ray to end up going downwards to the right, and the only one that would really deliver that is option A. A prism is made from transparent plastic. In this plastic, light travels at 0.8 speed of light. Light enters one face of the prism at right angles as shown, and we can see it travels along the boundary there. What is the angle theta? So there are 2 stages to this. The first thing we have to do is figure out the refractive index of the plastic, and we can do that using the speed light travels. We can see that it's trying to go into air, so the refractive index after that boundary is 1. So then what we can do is, what we're looking at here is the critical angle, because we can see it goes along the boundary. So the angle of refraction here is 90 degrees, and sine of 90 is 1. So putting that all together, we are going to get this expression, which we can rearrange to solve for theta, and it comes out at 53 degrees. The sun emits infrared radiation and light. Light from the sun reaches the Earth in 8 minutes. Which row gives correct information about infrared radiation? So infrared is at the red end of the visible spectrum, so it's longer wavelength than visible is, but in a vacuum they all travel at the same speed, so it will take the same time. A dolphin has a range of audible frequencies of 150 Hz to 150 kHz. Which range of frequencies can be heard by both humans with good hearing and by dolphins? So humans can hear anywhere between 20 and 20,000 Hertz. So if they're both going to be able to hear it, it's got to be 150, because then both the dolphin and the human can hear it. So it's got to start at 150, which means straight away we know the answer is D without even checking anything further. But at the upper end, it's going to be the humans that put the limit on the frequency. A permanent magnet is placed close to a soft iron bar. Okay, what are the polarities of end P and Q? So a soft magnetic material will align itself with an external magnetic field, so it will end up being a magnet in the same direction as the permanent magnet, and that's going to mean that P is the south pole and Q is a north pole, and then the iron bar would be attracted to the permanent magnet. A steel magnet is placed inside a coil of wire. Which method would demagnetize it? We need to apply AC, because we need the magnetic field to be constantly changing so that all of the different domains get aligned in different directions, but we need to slowly remove it as well. The electromotive force, or EMF, of a rechargeable battery is 6 volts. What does that mean? So 1 volt is 1 joule per coulomb. So let's have a look at that. Which one? Maximum energy in 1 second would be power, so that's not a volt. Total energy again, nope. The energy provided by a battery to drive a charge of 1 coulomb, yeah, that sounds good. We've got energy per coulomb. A student measures the potential difference across a device and the current in the device. Which calculation gives resistance? Resistance is potential difference divided by current. A water heater is connected to a 230 volt supply and there's a current of 26 amps in the heater. It takes 20 minutes to heat the water to a required temperature. How much energy is supplied by the heater? So power is calculated doing current times potential difference. Energy is power times time. So energy is current times potential difference times time. We have to remember to convert time into seconds, and that's how we end up with option D. Which symbol is a diode? That's B. You just have to know that. A student sets up this circuit. So in that circuit diagram, I can see a battery, a thermistor, and a bell. So what's the purpose of the circuit? So to allow a lamp to be made dimmer, well, there's no lamp in that circuit, so that wouldn't work. To amplify the sound of a voice, no, there's no speaker or amplifier in there. To light a lamp, there's no lamp there. So it's going to be option D, sound a bell when temperature rises. That makes sense. The diagram shows two voltmeters P and Q connected to a potential divider. The sliding connection at point X is moved towards the top of the diagram. What happens to the reading on P and the reading on Q? So when you slide it upwards, the resistance below X increases and the resistance above X decreases. If the resistance below X increases, the potential difference across it must increase. So Q has to go up and P must go down, because remember the 2 voltmeters added together must equal the EMF of the battery. Okay, so we've got a diagram with a digital circuit using a NOR gate and an AND gate. So what is the truth table for this circuit? So the way I'm going to approach this is using this AND gate at the end. So if Z is off, the output must be off too. So that allows us to eliminate C and D straight away, because we've got Z being off in the top line and the output is 1, which doesn't make any sense. We can also use the fact that if the NOR gate's output is off, again, the output must be off. So if you look at the bottom layer of A, if X and Y are both on, the NOR gate would output 0. So the output should be 0, but it isn't, and that leaves us with B being the correct answer. Which statement about electromagnetic induction is correct? A strong magnet held stationary near a stationary conductor causes a greater effect than a weak. Nope, neither of those would cause any induction. The effect occurs when a magnet and a conductor are both moved with the same speed in the same direction. No, because if they're moving together, there's no relative speed, so again, no induction. The effect occurs when a magnet is moved away from a nearby conductor. That would cause induction. The effect only occurs when the magnet is moved towards the conductor. No, it can happen when it's moved away as well. That means option C is the best description there. Diagram shows a current carrying conductor in a magnetic field. Which arrow shows the direction of the force acting on the conductor? So the thing to remember is current comes out the long side of that battery. So current is going up or into the page in your diagram. So that's where my middle finger of my left hand is pointing. The field is going from right to left because it goes from north to south. So you can see my thumb is pointing upwards. That's going to be the direction of the force. Power losses in transmission cables are reduced by increasing the transmission voltage. What is the explanation for this reduction? I'm using P equals I squared R to think about this. So if you can decrease the current, that decreases the thermal energy loss. In the atomic model, an atom consists of a central mass orbited by much smaller particles. What is the name of the central mass and the orbiting particles? Well, the central mass is a nucleus, so it's got to be C or D, and the orbiting particles are electrons, so it's going to be D. Nuclear fusion is a reaction that takes place in stars. Which row describes this reaction? So fusion, you take 2 nuclei and you combine them together, and that releases energy. So that is clearly option D. The diagram shows emissions from a source passing through an electric field between 2 charged plates. What is emitted by this source? So looking at this diagram, we've got one that goes straight on, which must mean that is neutral. And we've got 1 which bends towards the negative plate, which must mean it's positive. So we need to look for one that has a neutral, and a positive. So A has 2 neutral, so that's not right. B has a negative 1, which we don't need. C has a positive and a neutral, so that looks good. D has negative and neutral, so that's no good. The graph shows how the count rate registered by a counter near to a sample of radioactive isotope changes over a period of a few days. The background count rate is 5 counts per minute. What is the half-life? So if the background is 5 counts per minute, that means at the start, 40 counts are coming from the source. So we need to find out when the source is emitting 20 counts per second, but we need to measure 25 because we've still got 5 counts of background. So we're looking for 25 when it goes to 25, and if you read that off the graph, that's clearly 2 days. So you have to remember to factor in the background here. That's why most people will get this question wrong.